What I've created here, or I've had Alejandro working with me create here, is a series of sun vectors, okay, for sunrise and sunset, so that you can perform an analysis on your current design, okay, of what rays are coming into the building and which rays are being blocked. Okay? So you'll notice that when you look at this, that there's 5 blocks that align over top of each other, and there are 2 that do not. Does anybody know why? This is December, and this is June. Now does anybody know why? What was that, Daniel?
Coldest and hottest?
Nope. Melissa's got it right there. So Melissa just said that there are reciprocal months that have the same angle. And I've been telling you guys this now for going on probably 3 weeks or 4. Okay? We talked about it in the last class. So the sun vectors are all written down in here, and we've already done it. So this is April, right? And April is a pretty cool month, right? That's the month we're in. Today's not a very hot day. Last week was hotter than heck. The week before it was raining. Okay? So April's not a very hot month. How about August? You all live in this area. Is August hot? Yeah. Guess what? Those 2 months have exactly the same sunrise vector. Or if they're not exactly the same, they're off by less than a degree. Okay? And so every month, right, the equinoxes are obviously both the same, right? Every month has a reciprocal month except December and June. Okay? This is the sunrise vectors. These are the sunset vectors. Okay, now we've prepared them for you with lines already created for this exact latitude. So the latitude that these vectors are for your site in Claremont. Okay? So now what is required of you is that you take your plan, you drop it in the middle of the circle. You notice that there's a plus sign in the middle of the circle, right? And that you now trim out all of the sun vectors that are not getting into the building. So you notice right here, if this was like X-ray beams, right? Anywhere there's glass, they're getting in. So is there quite a bit of sunlight coming in the morning? There is, isn't there? Okay. The one that will surprise you guys is when you pass the equinox. So when you pass the equinox, right? This is August, right? That's right after or right before the equinox, because it goes in reverse. Or no, that's 2 months after the equinox. Let's see. This is the equinox at September and the equinox at March. So what you'll find is that, holy cow, if I have windows on the north side of my building and I have windows on my east wall, now we made this little generic building with no wall, no windows on the east side, on the north side. But more than likely, you do have stuff on the north side. You've got to do something to keep those early morning rays from getting into the building, especially in August. Okay? So what your task is going to be for both sunrise and sunset to cut out all the vectors, okay? And then I want you to make sure that you can tell me. For right now, that's what you're going to be doing during class right now when we're not giving you a crit. Okay? So this assignment is due by the end of class. So you're to take your current floor plan, drop it right in the center of the X. You might have to expand the rays. So maybe there's not enough rays there. Maybe your plan sticks out a little bit. So you'll have to offset the rays 6 inches. That's what these rays are offset by, right? To expand it whatever you need for your plan. All right, is there any questions about that? This will be one of the analysis components that gets shown in your final presentation. Any questions about that? I'm going to put this file, right, exactly as you see it right here, on the class server so that you guys can get to it. All right? No, I am going to put it on the class folder. That is, watch, save as, CAD Lab, arch202, right? And then I'm going to put arch202 Spring 2018, and I'm going to put it inside of Project 1, all right? And it's called arch202 Sunrise Sunset Vectors to Plan. Do not open it on the server. Please copy it to your local drives and work on it there. Are there any questions about what you have to do? Okay, your plan needs to have the windows shown. One thing that might be helpful to you, okay, is to potentially create a closed polyline of the parts that have to be cut, okay? This is trickier than it looks because, for example, when you don't cut these vectors here, they keep going out the other end here. Now you've got to trim them on the inside here, okay? But in the end, that gives you a pretty clear picture of how much sunlight's going to come in the morning. And in August, that's a problem. That's a big problem. Okay? All right. Yes?
Would you like us to show our overhangs or just the floor plan?
The overhangs cannot compensate for sunrise.
Oh, yeah, that's true.
Okay? So for sunrise and even like, say, depending on time of year, maybe an hour after sunrise, there's no overhang. You guys already determined that, right? Your overhang, just to block out part of it, had to go out 70, 80 feet in each direction. You remember that? That's part of this lesson. I'm going to have, where's Alejandro? He's sitting right there. I'm going to have Alejandro prepare something very similar to this for your sections. Okay? So the solar noon angle in relationship to your house. Now, that one's going to be different because that one you're going to have to show me. First of all, you're going to have to show me in plan what are the rooms that you're using for solar collection, for solar heat gain, right? And then you're going to have to do a section through each one showing this, right? And then you're also going to show me in plan where the heated area is of the slab or whatever other components are in there that you're using the sun to warm up. Okay? All right. I'll stop that there, and it's already saved.